I'm going to use a highlighter and a pen. So if you have access to a highlighter, I would grab one or something because we need to start being more intentional about what the problem is saying. And I'm saying that because we need to keep our eyes peeled for experiments and like weird stuff. So I'm going to highlight the problem as I read it, basically anything I think is important. Okay. Now I realize that this says example 2 and example 4. I stole this page from Teachers Pay Teachers. I'm too lazy to change any of that stuff. So the classwork is these two and these two. I don't care what they're numbered. All right. Okay. Example 2. You toss a coin 30 times. I'm pretty sure the 30 is going to be important. And it lands on heads 60% of the time. Okay, this problem right now should feel like trash ball to you. Do you know what I mean by that? Like you're performing a simulation like trash ball. Okay, calculate a 90% confidence interval for the actual proportion of number of heads. Okay, I think that's all I need from that guy. So the goal for today is to practice. We're working on our memorization through basic muscle memory here. So just straight up repetition so that when you have this, it'll just come straight out of your pen. Seal, pen seal, unless you have erasable pen. State. Okay, in the state, I want to start with my confidence level. So 90% confidence interval for P equals the true. And you can replace true with actual. That means the same thing. So I'm just going to say true and then find the word that's the same thing as true. Okay. So what this problem is saying is um how much the proportion of heads if I kept flipping the coin forever is what I'm going to estimate. And you should think it should be 50-50, right? If it's a fair coin-ish. Okay, are you guys understanding what we're doing? So we're taking our sample of coin tossing and we're going to do an estimate. We're doing an estimate. We're not doing a verb. We're doing a noun. We're doing an estimate of what the proportion would be if we kept flipping the coin forever. Okay, plan. First, state the method. Is this one sample or two sample? I'm going to give you a hint. It's in the title. One, but you could hopefully tell that it's one from the problem. Okay. Now, the reason I like these problems, especially on this sheet that this teacher made, which was really helpful, is they've got all kinds of weird stuff going on. Like this one, it doesn't say random, but I don't feel like it's an experiment either. I still feel like it's a random sample. What did we do for trash get ball when it didn't say random? Assume, right? Okay, what's n in this problem? 30. I think I can imagine tossing it 300 times. I don't want to. That'd be terrible. But I could. Okay. Now on this one, I have spoiled you with giving you the number of successes and failures in these problems. This one doesn't have it. It says you toss a coin 30 times and it lands on heads 60% of the time, which means you got to go back to the n times p. Like, don't forget n times p is still a thing. So n times p is greater than or equal to 10. And n times 1 minus p is greater than or equal to 10. So sometimes you actually have to go back to the formula, the secret formula, the secret Krabby Patty formula. Plankton's trying to get it at all times. No one, no one. Everyone has better parents than I was. Anyway, okay. Any questions so far? Anyone want to say anything yet? Anything you need so far? Okay. Let's grab our yellow sheets for the do. Okay. All right. Statistic. What is the statistic in this problem? Well, let's actually say, what's p hat? 0.6. Does that make sense, everybody? Are you sure? So remember, p means proportion. It's got to be a decimal. Okay. C star. I'm actually going to find it. And I also went into my calculator this morning to do one, and the parentheses were missing. So we have to remind ourselves what to do in case they're missing. Oh, I'm pasting that into Y1. That's not going to be helpful. Okay, and remember, it's absolute value, so 1.645. And as soon as this comes up, you'll be like, oh yeah, it's 1.645. I think this is the second most common one after 95%. Okay, so I'm right here. Statistic. Right here. Statistic plus or minus critical value times standard error of statistic. Okay, so standard error of statistic is right here. This is a one sample situation, so I'm right here, which is 0.6, 1 minus 0.6 over 30. And you might be at the point where you can just, because you know the 0.6, you have that part memorized. I got 0.089. Anyone else get 0.089? 0.15. Oh, I should know that. It's lame. I have to be honest with you and tell you that I don't feel like this is a monumental discovery. I'm pretty sure that I could have guessed before doing all of this math that if I kept tossing the coin, it would be somewhere between 45 and 75% heads. Um, but that's cool. It makes me feel like this coin might be unfair, slightly weighted to the head side because it might be more often than 50-50 more of the time. Now I'm interested. See, before I didn't care, but now if the coin is possibly weighted, then I actually care. Okay, anyway. Okay, move down to the bottom. This is your favorite. I'm making you do it, whether you like it or not. Okay. All right. What do we do? Yeah, so you guys can say that. I think I said if we take many random samples. Uh, but you can say over many. I don't care. I put tosses because it's coin tosses. Okay, what's next? By the way, last year I put calculate. I want you to know that if you choose a different word that means the same thing, it's okay. Okay, when you're ready, go over to the next one. We're not going to do this one together. You guys are going to do this one in your groups, but I do want to highlight it together. And there's a very big reason I want to highlight it together. So I'm a discerning customer, which means that when I read these problems, I'm trying to think about the conditions and things like that. And the first thing I started reading this, and it says a new drug trial finds that 32% of 125 participants. And then I was like, oh, that's an experiment. And I was like, oh, am I gonna have to use experiment stuff in the conditions? And I was like thinking about it. And then I was like, but it doesn't say anything about randomness. And now I'm all confused and maybe it doesn't work. And then I got to the end of the problem and what does it say? I didn't even have to worry about the conditions because it says assume all conditions are met. So I don't actually need to do any of that. I just need to state the inference method in the plan. Now, for me, because I'm you know how I am. We've discussed how I am. I'm a weirdo, like a Virgo, literal, like linear thinker. I put on my key, I put conditions met check mark because I just couldn't possibly just skip over it. Just couldn't do it. Anyway, but all right, so what else do I need? 32% of 125 and then 99.7 confidence interval. I think those are the other important things from that problem. Okay, but that's exciting because if it says assume all conditions are met, you don't have to sit there and critically think about what type of problem it is, even though I did anyway, because I'm nerdy. Okay, now go to the other side. We're gonna do the one on the left together. Okay. Women diagnosed with breast cancer were randomly assigned. Oh, there it is. That means this is an experiment. So I need to think about experiment stuff when I'm doing the conditions, which is easier. Either okay. 347. Oh, this is sad. What? I mean, to be honest though, if you were working for a prescription drug company, what else would you study? It's realistic, sadly. The thing that freaks me out is when I'm watching my YouTube and all of the ads come up with prescription drugs and the side effect list. Holy moly. I'm like, whatever condition you have must be terrible for you to suffer the possible side effects of this thing. Anyway, moving on. Okay. State, California. No, you will not get credit if you put California there. Please do not put a like geographic state there. If you put like, haha, Mrs. Salvet, California, it's like, I will probably laugh. No. Okay, anyway. Okay. 95%. Great. We like 95%. Less work. 95% confidence interval for okay. So oi oi oi. Okay, it looks to me this is really a depressing problem, but I think I'm gonna go PS for P surgery and then PN for no surgery. Is that as best I can do in this situation? Okay. Does this make sense to you? Surgery minus no surgery? Okay. I think I avoided the situation altogether last year and I did 1 minus 2 because I just couldn't anyway. I am too. Yikes. Yeah, where was he? Okay. Clam. What kind of a thing is this? Ooh, sample. Nice. Yes, honey. Well, it's not going to be Z forever. It's a Z. Just get yourself in the habit of it because I haven't taught you yet what else it could be, but it's Z for now, but it's going to be something else later. Yes. No. Okay, why not? And this is a great question. To be honest, Theo, I wouldn't mark it wrong, but it is wrong. Why would we not put PS minus PN here? Yeah, this is the method that you're using. Um, so I get my method based off of this, like this is it, you're saying what instructions you're following, basically. So this should be generic and this should be specific. Now, again, if you forget that and you put PS minus PN here, I'm not going to mark it wrong. But just to be picky, this should be general, this should be specific. Okay, anyway. Mhm. Oh, you have to look at what the sample was of. So if it says, yeah, okay, so it says we're not doing 10% in this one, but let's just say we were. You would say n equals 347 is less than or 10% of, and then you look at the 347 and you take that out and put the word all women who had surgery. And that, so it's basically whatever the sample is, you take out the number and replace it with all. Because you don't want to make it too specific. Your question is extremely valid because you can't take just a sample of the successful ones. Like that's what people's mistake are. They'll put 347 women who had surgery and eventually died. That if you knew that, then why would you do statistics? Your sample is just of people who had surgery. So when you're doing the 10%, just take whatever the sample is. So 30 tosses of the coin or whatever, and then change it to all. So take that number and change it to all. Okay, in this problem though, it's an experiment. So 10% does not apply. Do I need to write this bit? No, but I'm going to write it because, you know, I'm special. Okay, now on this one, we have successes and failures, right? Oh no. Okay, I know 16 is greater than or equal to 10. What's 347 minus 16? 331? 331 is greater than or equal to 10. 31 is greater than or equal to 10. 317. Look at me go. I know. Just move on. Just move on. It's all made up. Okay. Okay, now I'm gonna go into space saving mode here. I told you guys yesterday to find the decimals separately and then subtract. I'm gonna write it and then find the decimals and then find the subtraction. So surgery is 16 out of 347. And not surgery is 31 out of 348. Those are really close sample sizes. Just saying. Everybody okay if I just write 1.96 for this one? Okay. Mm-mm. You don't have to write even this. You could just plug it straight into the thing. You don't have to show any calculators stuff for inverse norm. And the reason is because um they're constant for every confidence interval for proportions. So they're all the same. Okay. So statistic negative 0.043 plus or minus critical value times standard error, which is big. Can someone check me? I got 0.019. Now, if I was a researcher, I would be very excited with these results. Does anybody see why? Mm, surgery works. Okay, now we're going to talk about, so I took these numbers from my interval and I just changed them to percents for our brain because this is easier for people's brain than this a lot of times. And what this means is if the entire interval is negative, that means PS minus PN is less than 0. This is a conclusion I'm going to make algebraically because this is negative. And then I'm going to add Pn to both sides. That means PS is less than Pn. Okay. If PS is less than Pn, yeah, that means that people die less with the surgery than they don't without the surgery. Okay, so I'm trying to get your conclusion from algebra here. You can maybe look at it and say that without this, but it helps people to like write out the algebra. Okay, so since our interval is negative, so the whole thing's negative. So get the surgery. I was going down some stupid rabbit hole about cancer, tumor removal surgeries. Don't ask. It's not anything about me. And they said it was like sometimes a bigger risk of infection or anesthesia from the surgery than the cancer itself. It's just people hear the word cancer, they think that they get like super scared and freaked out, but some of them are like really slow going and they'll actually die of something that like this old age before that, and then people go through all these like super invasive treatments for no reason. Anyway, I don't read that stuff. Just don't grab a hole with medical stuff on the internet. That is just the theme of today. Okay. Any questions about these two? All right. So I have the other two completed. I want you to work on those in your groups and then check them back at my table. And then start working on your chief test. I'm gonna come stamp last night homework and yesterday's stuff. Those words you get properly. Okay. Yeah.